So if you checked over examples 2, 3, 4, you may have had different answers, but as long as they followed the same parameters, they were still correct. Here we have something a lot more specific. So we're closer to having just one correct solution. So if I knew everything about g of x, which is x cubed minus 6x squared plus 9x, I would know that there's exactly one graph that works. So all of our graphs should look the same for this one. So I'm just going to take it piece by piece and label what it means and then try to put it on a graph. So my end behavior, I'm going to look at some limits as x goes out to infinity. So as x goes to negative infinity, the limit is negative infinity. So as x goes to negative infinity, that means as I go out to the left, my left arrow should be pointed down to negative infinity. My limit as x goes to positive infinity, that means we're going to the right on the graph. My end behavior should be up to the right. It's going up to positive infinity. So my end behavior overall for this x cubed function is down up, which might be something you remember from algebra. The next thing I'm given is there are no asymptotes, so there's no vertical or horizontal asymptote for me to draw in a dotted line at. I'm increasing from negative infinity to 1 and 3 to infinity, but then decreasing 1 to 3. And I usually like to just make these into sign charts like we did before. So I'm just going to label my critical numbers in here. 1 and 3 are the places where my derivative is changing. Before 1, I'm increasing. And after 3, I'm increasing. And then between 1 and 3, I'm decreasing. So it gives me a pretty good idea of what the shape is going to look like. I'm going to go increasing to decreasing, and then I'm going to go back increasing again. So it's going to look something like that, and that gives me my relative extrema, which I'm already given on the next line. So my relative max is at 1, 4. So this is the first thing I can put in. I definitely go through the point 1, 4. There's my relative max. My relative min is 3, 0. I'm going to plot that point there. I'm given my concavity. I'm going to make that into a sign chart as well so I can get a sketch of what this looks like. So my concavity is changing at 2. From 2 to infinity, I'm concave up. And from negative infinity to 2, I'm concave down. So I could draw something that's concave down and switches to being concave up. And then my point of inflection would be kind of in the middle of the two concavities. And that inflection point, or point of inflection, is at 2, 2. That should look like it's between being concave up and concave down, kind of part of neither. So now I can sketch all of this information. So I want to make it look like I am having a relative max at 1, 4. So I should be increasing to decreasing there. And I can use my concavity as well to get this picture correct. So I'm going to draw my relative max in here as best as I can. So my relative max that I'm going through, my point of inflection should look between concavity, and then I'm switching to be concave up. So it would look something like this. And of course, to make it a more accurate drawing, another thing you could do is figure out maybe the y-intercept of the graph, something like that would help you figure out a better picture. But all of our pictures should have this general shape and go through the points 1, 4 for the max, 3, 0 for the min, and then inflection point 2, 2.